Okay. So today we're going to learn something called counting techniques. So even though it looks simple, we do accounting, but a lot of times actually we're making some mistakes. Now, let's see. There's something very interesting to count numbers. Now, if we have number like 1, 2, 3, 4, 5, and to 13. Now we know there are 13 numbers. What happens if you count from 6, 7, then all the way down to 21? Now, how many numbers are there? Okay, you can type on the chat. Okay, what do you think when you get those numbers? Yeah, type on the chat from 6 to 21. How many numbers we got? Okay, Raji? Okay, so you all get 15, and that actually is a simple, uh, it's a simple mistake because we just use 21 minus 6, and we miss by 1. The reason for that is, if you look at the first one, we know there are 13 here. Now, but if we use 13 to minus 1, we only got 12. We're missing by 1. So there's a simple counting mistake is when you trying to figure out numbers, you use the last number minus the first number, but you have to add 1 to it. For example, 7, 8, 9. If I just do 9 minus 7, I only got 2, but we got 3 here, so you add 1 to it. That's 3. Or say 20, 21, all the way down to 27. And if we do 27 minus 20, we got 7, but we actually got 8 of those. So you can see 20, 21, 22, 23, 24, 25, 26. We actually got from 21 to 27, we got 7. Then the 20, we had to add 1 to it, so it's 8. So that's a very common mistake, easy to make, but I'm off by 1. And this is actually quite a famous error, counting error. Okay, now you know how to do it. I'll have you try, say, 42, 43, and all the way down to 79, and see what you got. Very good, Mason. Yeah, make sure. And if you are not quite sure, you're just looking at, try something simple. Let's say 2, 2, 5. 2, 3, 4, 5. So 5 minus 2 is 3, but we got 4 of those, so we had to add 1 to it. We got 4. So that's the how we do it is the last one minus the first one, then we add 1 to it. Yeah, good job, Mia. Yeah, again, when you are not quite sure, you can always just try and do something like this. This is very simple. You know, you got 4 of that, but 5 minus 2, only 3. So you have to add 1 to it. So it's always last minus first, then add 1 to it. And Rodri, what's your answer? Okay, so on this one, we just go 79 minus 42. That give us 37. Remember, we have to add 1 to it. So we add 1, we got 38. Okay, so now let's see. What's that? Okay. Okay, so try just 25, 26, and all the way down to 40, and see what you got. Good job. Good job, Mason. Good job, Raji. Good job, Mia. Okay, so remember we have to add 1. So 40 minus 25, that give us 15. Then we add 1 to it, becomes 16. Okay. So now let's move on to something very interesting. Like say from 10 to all the way down to say 79. Now, how many multiple of 3? Well, if we're going to figure it out, that takes a while. Multiple of 3, because it's going to be 12, 15, and 18. Then we have to keep going. But in this case, we just figured out the first multiple of 3 in between 10 and 79 is 4 times 3. And then get to here, what closes 79? If you 79 divided by 3, we got 2, 6, 19. So that's 6. And so that means 3 times 26 is less than the less than 71. The next one will be bigger than 79. So the last multiple in this interval will be 26 times 3. So now we just figure out 26 minus 4. That give us 22. And we just add 1 to it. So we got 23 multiple of 3 in between 10 and 79. Okay, are we good on this one? If you're good, could you give me a thumbs up? Thank you, Mason. Thank you, Raji. Thank you, Mia. Grayson, are we good? Okay. All right, now I have you do a problem here. Now we're looking at 27, 28, all the way down to 85. We are looking at how many multiple of 5. So how many multiples of 5? Nancy, what's your answer? Good job, Mason. If you're not quite sure, you can also type ABK. So hello, Rosie. What's your answer? All right. So the same thing like we did multiple of 5. We're just looking at what is uh the multiple of 5 that is just a little bit bigger than 27 is 30, which is 6 times 5. And then here, 85 is where is my, yeah. So 85 is 17 times 5. That means we have a 6 times 5, 7 times 5, 8 times 5, and all the way down to 17 times 5. Remember how we did if we do counting 7, 6, 7, 8, 9, all the way to 17 is this number, last one minus the first one, add 1. So in this case, it will be 17 minus 6, which is 11, we just add 1 to it. And that gives us 12. So again, when you do things like that, if you're not quite sure, just try something very simple. Like for example, 5, 6, 7. You can see that 7 minus 5 is 2, but we got 3 here. So you have to add 1. If you want to do 4, 5, 6, 7, we got 4 here, but 7 minus 4 is 3. So we just need to add 1 to it. So last one minus first one, then add 1 to it. Okay, are we good here? Thank you, Mia. Thank you, Mason. Thank you, Grayson. Thank you, Roger. Okay, let's try 32 to 69. We want to find how many multiples of 4, okay? Yeah, again, if you're not quite sure, you can always type IDK. John Mason. Yep, Mia, what's your answer? Okay, so yeah, so the correct answer actually is 10. Well, let's see why that. First of all, 32 is 8 times 4. We just want to figure out that close to 69. 69 divided by 4, we got 1, we got 4, 29, so 17, 28, and remainder 1. That means 17 times 4, that is just 1 from that, the closest to 49. So how many multiple 4? We can say from 8 times 4, 9 times 4, all the way down to 17 times more. Basically, we're counting from 8, 9, all the way to 17. Remember how we did early on. We're going to use this minus that, add 1. So 17 minus 8, that gives us 9. 9 plus 1 gives us 10. Okay. And you can always checking it. You got 10, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you count it, you'll get exactly 10. Okay. Are we good on this one? Thank you, Mason. Thank you, Raji. Thank you, Mia. Thank you, Grayson. Okay. Let's try one more, okay? 13, 14, and all the way down to 32. Now, we're going to count multiple of 7, okay? Multiple of 7. Good job, Grayson. Good job, Mason. Okay, Rodri. Yeah, we're counting multiple of 7 or multiples of 7. Okay, let's see. Since we're talking about multiple of 7, and we know this one's 17, 2 times 7. And when we got 32, the one closest to 32 is 28, which is 4 times 7. Well, this is actually pretty easy. 2 times 7, next one 3 times 7. We got this 3. 2 times 7, 3 times 7, and 4 times 7. Or you can use the trick we did early on. 4 minus 2 is 2 plus 1, give us 3. Okay, are we good on this one? Thank you, Mia. Thank you, Mason. Yeah, Rodri, are we good? Okay, let's see. Can we go give you a last one here? And we can move on. Say 21 to 45. We're going to count multiple of 3, okay? Multiples of 3. So how many of those between 21 and 45? Good job, Mason. Yeah, good job, Rodri. Very good. Yeah, so we can start with times 3. we ends up with 9 times 3. Sorry, not 9. We got 15 times 3. Okay, so just using, so basically we're talking about 7 times 3, 8 times 3, 9 times 3, then all the way down to 15 times 3. So that's the same as we counting numbers from 7, 8, all the way to 15. Like we learned early on, that will be the 15 minus 7. That give us 8, but then we add 1 to it. Got 9. So the add 1 part, if you're not quite sure, you can always just like said early on, check some simple things like 4, 5, 6. 6 times 4 is 2, but we got 3, so we had to add 1 to it. So that can help you to remember to add 1 to it. All right, now we're going to learn something called the fundamental counting principle. So big word, but actually turns out to be pretty simple. Well, a lot of fundamental things are simple. Just like, you know, any foundation, not much. It's not that interesting, but that's a foundation. So without that, you won't be able to do anything else. So they call the fundamental counting principle. The fundamental counting principle comes really easy. It's like if you have 2 or more than 2 decisions to make. So we're just looking at 2. We got 2 decisions to make. Let's say if you go to a fast food restaurant and you have to choose what kind of meal you have. Well, let's say you have 4 choices, and then you're asking you what kind of drink do you have. So this is a meal, this is a drink, and nowadays those are quite expensive. So we got 3 different kind of drinks. So we're trying to figure out how many different ways we can have. And the fundamental counting principle just says that if you have 2 decisions to make, for the first decision you got 4, and second decision you got 3, you simply just multiply, just 4 times 3. Okay, and in terms of principle, they're actually using this. The first decision, we got A choices. Second decision, and we got first. Second, and it's B. Then the number of choices will be, total number of choices be A times B. So, and that's it. Now, if you got more than 2, let's say you have 3 decisions, then say if you have 3 decisions to make, and you have, for the first one, you got A choice. Second one, you got B choice. Third one, you got C choice. Then the total number of choices you can have will be A times B times C. Okay, are we good here? Yep. Roger, are you good? Okay, so it's pretty straightforward. Let's see. Again, if you go to a restaurant and you got choice of, say, 5 different meals, and you got say 3 choices on the sides and 4 choices on the drinks. So how many different choices do you have? The total number of choices do you have? Oh, remember it's multiplication. Good job, Mason. Good job, Grayson. Good job, Mia. So basically we'll simply multiply 5 times 3 times 4. And we got 5 times 4 is 20. 20 times 3 is 60. So that's how many choices we got. Okay, are we all good here? Yeah, thank you, Grayson. Thank you, Mia. Thank you, Reese. Mason. Roger, are you good? Okay, so now we can use the same thing when we're trying to, let's see. Now, in a class, we have 12 boys and 15 girls. Now, if we want to pick a boy and a girl to represent the class, how many different choices will we have? Yeah, good job, Mason. Good job, Grayson. Good job, Mia. Roger, well, what's your answer? Okay, yeah, so basically it's 12 times 15. And if you use calculator, that pretty easy. Now, if you just want to either do it in your head or just on a piece of paper, you can make life easier by breaking this into 6 times 2. Then we know 2 times 15 is 30. So that becomes 6 times 30. And 3 times 6, 18. So 180. So we can do that pretty easily. Okay, let's do one more problem. Let's see. Um, and now let's see if we're going to try to make a password. No, we'll do that a bit later. I'll just like say, oh, I am okay. Let's say you have two numbers. And you can for the first one, you pick from number 1, 3, 5, 7, 9, all the odd numbers for this one. Now, for this one, we'll pick a letter from A, B, C, D. Now, how many different passwords that you can make? Good job, Roger. Good job, Mia. And so that actually is 20 because we got 5 choices for the first one, and second one is 4. So according to the fundamental counting principle, we got 5 times 4, we got 20. Very good. Now we are going to learning something called permutation. You probably heard that. Permutation, big word. Permutation just trying to figure out how many different choices or uh, uh, or how many different options that we're going to have. And it has to do with the order is important for permutation. So if you have something like, say, A, B, C versus A, C, B, they are considered different permutations. And there is a two flavors of this. One is with repetition. Repetition. That means you can choose the same thing over and over. Okay. For example, now if I want to make a password, we got 3, and I can choose from the letter A, B, C, D. Since we are allowed for repetition, that I can have all A's. Okay, so in this case, we can see that how many choices for the first one? Well, we got A, B, C, D. We got 4 choices. For the second choice, we also have 4 because it can we allow repetition. And then the third one will be 4. So that's 4 times 4 times 4. That gave us 64. And versus another type of permutation is permutation without repetition. So permutation without repetition. That means you cannot reuse any, once you use a letter, you cannot reuse it. So let's, in this case, how many we got? For this one, we got 64 because we can use repetition. Now for here, we still have A, B, C, D, but we can only choose, once we choose a letter, we cannot reuse it. So therefore, for the first one, we got 4 choices. We can get A, B, C, D. Now, second one, we only have 3 because we already picked one for the first digit. So we got 3. And the third one only have 2. So we only have 4 times 3 times 2. That equals to 24. You can see that this got 64. This only got 4, 24. Okay. Are we good on this one? Okay. Thank you, Mia. Thank you, Mason. Thank you, Grayson. Roger. Okay, very good. So now let's see. Could be problem. Let's say you have a combination lock, which is kind of like a lock like this, and they got blocked, and you have those wheels there, which are numbers. You can see numbers there, and you can choose numbers. Now, so let's say we got 3 wheels, and we can choose digit 0, 1, 2, 9. Now, in this case, how many choices can we have? Like, say, if you want to pick a number, your secret number, to open this. Now, how many secret numbers can you have? So think about, is that a permutation with repetition or permutation without repetition? Yeah, think about how many choices for the same first one, how many choice for the second number, how many choice for the third number, okay? Then we use the fundamental principles. Mm. Good job, Mason. Roger, what's your answer? All right. Okay. Think about in a combination lock, each will actually have 10 digit, 0 to 9. So for the first will, the choice you have is 10. Second one also have 10. Now, third one also have 10. Now, according to the fundamental counting principle, we got 10 times 10 times 10. We got 100, 1,000. So uh, that's why a combination lock uh, is useful, because once you pick a number, in order to guess your number, then this is 1 out of 1,000 chance. So the chance for people to guess it right is pretty small. Okay, are we good on this one? Yeah, thank you, Mia. Thank you, Mason. Thank you, Roger. Grayson, are we good?
Hi, sorry, Grayson had to hop out for a sec, but he said yes.
Okay, all right, thank you. All right,
Yeah, sorry.
thank you. Okay, so let's check on something which a little bit easier. So we got a 4. We're going to pick we're going to make a password, and we're going to choose from uh, all the vowel A, E, I, O, U, got 5. Now, if we allow the repetition, that means we can reuse the letters. Now, how many choices we can have? Good job, Mason. Remember the fundamental counting principle. So the number of choices we're going to actually multiply. So figure out how many choices for the first letter, how many for the second, how many for third, how many for the fourth. Yeah, Mia. Okay, let's see for this one. We know we have 5 choices here. And second letter, also 5. third letter, 5, last one, 5. So it's 5 times 5 times 5 times 5. So this is actually 5 times 5, 25, and times, this is 25. That gave us 625. Okay, are we good here? All right. Yeah. Okay. Now, if I change this, we're going to count how many choices we have if we cannot reuse letters. So we can only have one A, one E, one I, one O, one U. But we're going to try to make up a 4-letter word. And so how many different words can we make? Good job, Roger. Good job, Mason. Okay, Mia, Grayson, what's your answer? Mhm. Well, we got a 4 letter. We're going to make 4-letter words, and this time we're still using from A, E, I, O, U, but we cannot reuse it. So this is a permutation without repetition. Once we use one letter, we cannot reuse it uh on the other letter other letters. Say if you use the A for the first one, you cannot use A for the second, third, or fourth. So this is called permutation without repetition. So how many choices in this case? We still use the same principle. Looking at what choices for the first one letter, how many choices on the second letter, how many choices on the third, and how many choices on the fourth. Yeah, Mia? Need help? Okay, so look at, because now we can, it's without repetition, so we look at the first letter. The choice we got for first letter is 5. But once that letter used, we only got 4 letter left. So we pick 4, third, and 3. Last one will be 2. So it's 5 times 4 times 3 times 2. And this gave us 20. And this gave us 6. 20 times 6, 120. Okay. Are we good on this one? Okay, thank you, Mia. Thank you, Mason. Thank you, Grayson. Okay, so let's, and you can see the difference. When we have repetition, we have a lot more choices, but without repetition, we really don't have that much. Okay. Now let's see our last one. You got 4 marbles, red, blue, and pink, and green. So now you're going to, so that's what you have, 4 marbles. Now you're going to pick the marble, and you're going to line them up. Okay, so you got first place here, second place here, third place here. And now how many different arrangement can you have? For example, you could have red, blue, pink, or red, pink, green, or blue, pink, etc. Good job, Mason. Yeah, again, I was trying to figure out how many choices for the first one. First location, how many choice for the second, how many choice for the third. Okay, all right, let's see. For the first place, how many choice do we have? Just type on your chat. Right. And okay, Mia and Mason and Grayson, how many choice for this one? Okay. Yeah, we got 4 here. And how many choice for the second one? Yeah, we got 3. How many choice then for the third one? Only 2, right? So we got 4 times 3 times 2. Then we got 12 times 2, 24. Okay, are we good on this one? Okay, thank you, Grayson. Thank you, Mason. Thank you, Roderick. Thank you, Mia. All right, that's all we have for today. Okay, I'll see you next week. Bye.